Good evening to all of you. Good evening, all of you. I hope you guys are fine. So till now in this OCF series, we have discussed about difference between the pipe flow and open channel flow, classification of open channel flow, then channel geometry. We have discussed like for every channel how to calculate RD for every channel, whether it's a rectangular, triangular. For every channel we have discussed, and you also have understood how to calculate R and D. I think that is clear to all of you. Okay. Next thing which we need to discuss here is the hydraulic efficient section. Now, hydraulic efficient section is the first topic which you need to discuss. I will say first topic. Why I am saying it's a first topic? Because before that, whatever you have discussed, all are nothing but the introduction part. All are nothing but the introduction part. First topic in OCF is nothing but the hydraulic efficient section only. Before that, whatever we have discussed, that are the things which are related or which are very important for you to understand, so that you can go with the main topics easily. Now let's start with the hydraulic efficient channel. So today anyway, topics to be covered will be the complete hydraulic efficient section. Today mostly derivation will be there, and starting with the first part, first term actually, that is the economical and efficient section. You may be like in your day-to-day life, you sometime you are hearing like, or sometime you heard this is the economical section or this is the efficient section. Is that a difference? Is that any difference between these two, hydraulic efficient section and hydraulic economical section? One is the economical section, another is the efficient section. Do we have any difference between these two? 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 Yes. So, hello Vikash. We have difference between these two. When you say economical, it is related to the cost, and when you say efficient, it is related to the output. Like for pipe or for OCF, here the output will be the discharge. So efficient means maximum discharge, and economical means minimum cost. Minimum cost. So one is economical, another is the maximum discharge. So this you need to understand it. This you need to understand it. Is that clear? Okay. Now in a hydraulic efficient section, for example, here you are focusing more on maximum discharge. So Q equal to area into velocity. If I do Q equal to area into velocity 1 by n, r radius is nothing but area by perimeter to the power 2 by 3, slope to the power 1 by 2. Now if you focus, my dear, if area and all everything I have taken as constant, so can I see this Q is inversely proportional to P? Can I say this? P is Q is inversely proportional to 2 by 3, or basically it's inversely proportional to perimeter. That means if you have less perimeter for a given area of cross section, you will have more discharge, and this something you can see practically also. If we have less parameter, less resistance will come, contact will be there, less resistance will be there, and definitely it will leads to maximum discharge, or it will increase our discharge, because less resistance in the same flow you are getting more discharge. This will happen. So if Q is more, P will be less, or if P is more, Q will be less. So there is an inverse relationship between Q and P. So here I have written channel is hydraulically efficient if it has minimum weighted parameter. So I think as a note you all guys can write down, channel is hydraulically efficient if it has minimum weighted parameter. Minimum weighted parameter. Is that clear till here? Till here, is that clear to all of you? Good evening, Vikas. Good evening. Is that clear to all of you till here? So for any cross section or for any channel, our intention will be to find out the minimum parameter thing. We are not focusing the maximum discharge part. Anyway, if minimum parameter will be there, maximum discharge will come. Maximum discharge will come. So we are focusing more on minimum parameter. Minimum parameter. Okay. Let's start. Let's start with the rectangular section. Let's start with the rectangular section. So here, this is the section. This is B. This is Y. Area is B into Y. B plus 2Y. Okay. If you write parameter in terms of area, it will be nothing but area upon Y plus 2Y. Okay. I don't think so anybody will have any problem. Priyanshu Mishra, good evening sir. How are you? I'm completely fine, bacha. Okay. So now here for hydraulic efficient section, for hydraulic efficient section, we know that P we need is nothing but the minimum value. So for that, P is nothing but what? A by Y plus 2Y. Okay. Now if you want minimum value, what we will do here? We can go for maxima minima. For minima, dP upon dy is equal to, we are differentiating this P with respect to Y. A will be taken as constant. So A, I am taking it out. This will be minus 1, minus 2, plus 2. And that will be equal to 0. That will be equal to 0. Okay. Now this will be minus A upon Y square plus 2 equal to 0. This will be A equal to 2Y square. Area you already know, B into Y is equal to 2Y square. Y and Y will get cancel out. So we are having B equal to 2Y. This become a condition. For what? For hydraulic efficient section in a rectangular section. In a rectangular section, hydraulic efficient section will come with this. So what we are doing here, we are not changing the area of the cross section. Without changing the area of the cross section, I have taken area as constant. If you are able to maintain width is 2 times of depth, or depth is half of the width. So in that case, that section will be called as hydraulic efficient section in rectangular section, and that section you are getting maximum discharge for that area of given section or area of cross section. For that area of cross section, you are getting the maximum discharge with this condition, B equal to 2y. So now this become a special case for us. So if B is equal to 2y, can you find out R for me? R will be what? Area upon perimeter. Area is B into y upon B plus 2y. So if you put B equal to 2y, it will be 2y square in the numerator divided by 4y. So R equal to what we are getting here, y by 2. R equal to what we are getting here is y by 2. Is that clear? R equal to what we are getting here is R equal to y by 2. Okay. So this is all about the rectangular section. In a rectangular section, the condition for hydraulic efficient section will be B equal to 2y, and for that if you need to find out R, it will be y by 2. It will be y by 2. Kindly note it down fast. Is it noted, everyone? Is it noted, everyone? Okay. So now I am going to the next part, that is a triangular section. So let me draw a triangular section for you. Now this is the triangular section what we are having. One is to one, we have the slope. This is y, so this will be my and this will be my. 1 is to m, we have given the slope as 1 is to m. This angle is theta, what we are taking. This angle is theta, what we are taking. So here if you take tan theta, it will be perpendicular by base, so m. So m is equal to tan theta here. That you need to understand it. That you need to understand it. Now here also if you write perimeter, formula will be 2y root under 1 plus m square. Basically summation of this length and this length will give you total perimeter, weighted perimeter. Now area also here it will be my square. This part already we have discussed in channel geometry. So now in place of y I can write now 2, it will be, or you can write like this. You can take square of this, let us say p square. So z is equal to p square, it will be 4y square. In bracket we have 1 plus m square. So z will be 4. In place of y square I can write a by m. 1 plus m square. 1 plus m square. So like this I can write. Like this I can write. I don't think so anybody will have problem. Like this I can write. So see, if you want P to be minimum, indirectly if you want Z as a minimum, definitely the P will also get the minimum value, na? So what we are doing here, just to remove that square under root part, we have taken a new term z, and that z is actually equal to p square. If you want p to be minimum, z will be also coming as minimum only. So we are finding out the minima condition for z, for minimum z basically. So in that case, z equal to 4a by m, 1 plus m square. Let us put 4 in place of a, keep that a only. M is nothing but tan theta. So 1 by tan theta is basically cot theta plus m. So it will be tan theta. Now same thing for maxima and minima. Dz upon d theta will be 0. This condition we guys are already knowing. This condition we guys are already knowing. So dz upon d theta is 0. What we are saying. So differentiate. 4a will be like this only. We are differentiating with respect to theta. We are differentiating with respect to theta. First thing is the cot theta. Differentiation will be minus cosec square theta. Minus cosec square theta. Plus tan theta. Tan theta differentiation will be nothing but sec square theta. Sec square theta equal to 0. So 4a anyway it's constant. Remove it. So you are getting sec square theta is equal to cosec square theta. So sec square is basically 1 upon cos square theta, and this is 1 upon sin square theta. Keep it one side. It will be tan square theta equal to 1. So tan theta equal to 1. So theta will be equal to 45 degree. And this become a condition whenever you want maximum discharge in a triangular section. In that case, for a given area, you need to always give theta as 45 degree. That means this vertex angle will be 90 degree. This vertex angle will be 90 degree. In that case, you are getting maximum discharge. And we already know that this is a special case we have already discussed during channel geometry discussion. During channel geometry, what we are getting for theta equal to 45, those who have revised, they can tell me r equal to. In a channel geometry topic, when I was discussing for triangular section, I have given a special case for you that when theta equal to 45, what will be the value of r? You guys can comment. You guys can comment. Those who are watching regularly, those who are revising regularly, they can tell me. Those who are watching regularly or those who are, they can tell me. R value will be nothing but y upon 2 root 2. You guys can check your notes. I have discussed this part during channel geometry. Kindly note it down quickly. Okay. So this part you all guys have understood. Anyone having any doubt regarding this triangular section? Anyone having any doubt regarding triangular section? Okay. So now we are going into the trapezoidal section. So let me here this angle we are taking as theta. You know that in a trapezoidal outside angle we are taking as theta. So what will be the difference here? In the triangular section, m equal to tan theta was there, na? Here 1 by m is equal to tan theta. Why? Because if you take tan theta here, this side will be y and this side will be so perpendicular y divided by my. So 1 by m will be there. So m will be equal to 1 upon tan theta. Here, according to this. This again, it's b only width. Okay. So first two things, that is the area. So area will be by plus my square. You guys are already knowing this part. And the perimeter will be b plus 2y root under 1 plus m square. This is the area and the perimeter. This is the area and the perimeter. Now here in a triangular section, as you know, it's a combination of rectangle plus triangle. So both type of thing will come. So here two cases can be possible. First cases is that, for example, if you are changing the slope of the, or you can say this is the second case by the way. If you are changing the slope of the side slope, if that you are changing, accordingly depth will also change. So that is a one of the thing, at what slope you are getting the maximum discharge, at what slope, at what theta value you are getting the maximum discharge for a given area of cross section. Another thing will be, you are changing the depth of this section without changing the side slope, you are changing only the depth. So two cases will be possible. So first case I am writing to all of you. So 2 times we need to actually derive it. No problem, we'll do it. First case is, depth is variable and side slope is constant. Side slope is constant. Depth is variable and side slope is constant. Side slope is constant. Okay. So let us do it now. Depth is variable. So here the perimeter we have p equal to b plus 2y root under 1 plus m square. B is something which is irritating us. So let us change that b part. In place of b, what we can write here from here? A equal to by plus, so it will be, this I can write like this now. A by y is equal to b plus my. So b will be equal to a by y minus my. A by y minus my. I think this I can write now. Actually, I want to remove this b part basically. I want to remove this b part basically, and for that I have done this. Okay. Now simple thing is that here also we are going for the minima dp upon Here we are differentiating with respect to y basically. So dp upon dy equal to 0 will be there. dp upon dy will be equal to 0 basically will be there. So if you differentiate this part, so a by y differentiation will be minus a upon y square, if I'm not wrong, minus a upon y square minus m plus 2 root under 1 plus m square plus 2 root under 1 plus m square equal to 0. Equal to 0. That's what I'm getting. That's what I'm getting. If you want, you can change this part also. Like you can write this as a upon y square is equal to 2 root under 1 plus m square minus m. So a will be 2y square root 1 plus m square minus my square. You can write like this. This I am doing it for some other purpose. So this point I am putting in a box. You will get the purpose very soon. Now look at here, my dear. Area formula already we have, na? Area we have. Area is nothing but b plus my, by plus my square. Put it here. By plus my square divided by y square plus m is equal to 2 root under 1 plus m square. Clear? So this will be by plus my square plus my square equal to 2y square root under 1 plus m square. Okay. So this is by plus 2my square is equal to 2y square root under 1 plus m square. That's what we are getting. That's what we are getting till here. Now things which are common, we can cancel it out. Like this will become b plus 2my. Y is common in both the part. 2y root under 1 plus m square. Now if you notice, my dear, this b plus 2my is what? Is nothing but the top width. Top width is this part. B plus 2my. That is nothing but the top width. So what condition which we got? The condition which we got that for this case, for hydraulic efficient condition, we are getting B plus, or you can say, right, you can write simply, T is top width is equal to sum of the length of the sides. Sum of the length of the inclined side basically. So a trapezoidal section will be called as a hydraulic efficient section. It will be giving you the maximum discharge when the top width is equal to the sum of this length inclined plus this length. In that case, this section is the hydraulic efficient section, and here area of the cross section we have taken constant. Area of section we have taken as constant. So this part plus this part will be given as top width. If this thing is there, it is nothing but the hydraulic efficient section, and that becomes a condition for us. That becomes a condition for all of us, that T is equal to sum of the length of the inclined side. Sum of the length of the inclined side. That you need to understand it. That you need to understand it. I hope it is clear to you. I hope it is clear to all of you. Kindly note down each and everything clearly. Kindly note it down each and everything clearly. This is the first case, by the way. This is not the complete discussion of trapezoidal section. This is the basically the first case. Second case will be also there. Second case will be also there. Now look at the second case what we are having. Case 2. Look at the second case what we are having. Second case, that means second case, if you want to note it down, no problem. Have you all noted down this thing? Have you all copied down all these things? If you want some extra time, you can take it. But I want you guys to note down each and everything clearly. Because these derivation, if you are not doing with me now, you will never learn. You will just simply mug up the final result, and that is not good for you always. So is it copied or not? Yes or no? Is it copied? Is it copied? Okay. So we are going to the second case. Now in second case, what is this? Side slope is variable. Last time side slope was constant, depth is variable, and side slope is constant. So this time what we are doing here, we are changing the side slope. We are changing the side slope. This is the slope now, side slope. So this we are changing it. This we are changing it. This we are changing it. That means theta we are changing it. Theta we are changing it. The good thing which you need to understand it, if you change the theta, if you change the side slope, depth will vary or not. They have not written that point, but my question is to all of you, if you change the side slope, depth will vary or not? Depth will vary or not? That is what something I am asking to all of you. So here also the perimeter will be the same formula which we have discussed, which we have written earlier. B plus 2y root under 1 plus m square. But as you know, if side slope will vary, depth will also vary, na? If you change the side slope, even depth will also vary, na? Depth of water will also vary, na? So the condition which we got in the first part of this is the area. Now this area I am using it here. This area I am using it here. So A equal to what we are having, 2y square root under 1 plus m square minus my square. So this part I am using it. This part I am using it. So P equal to what we are getting here. This part I am using it. I hope you have understood this part. So this part I am using it. Okay. So P equal to area, this B part, again I can write in this way, which we have written here. In place of B, I have written A by Y minus my. So A by Y minus my plus 2y root under 1 plus m square. Now in place of A, I am putting this thing. This part I am putting it. So this become 2y root under 1 plus m square. Very good. Minus my. Okay. Minus my plus 2y root under 1 plus m square. So ultimately perimeter what we are getting here is 4y root under 1 plus m square minus 2my. This is the perimeter what we are getting. This is the perimeter what we are getting. Now you know that for maxima and minima value, for maxima and minima value, dp upon dz, dp upon dm here will be equal to 0. So let us do that. First will be 4y 1 plus m square. Differentiation, it will be 1 by 2. Then root under 1 plus m square. And here it will be 2m. I hope it is clear to you. Minus 2y is equal to 0. That's what I'm getting. That's what I'm getting. So this becomes 2my, sorry, 2 and 2 will get cancelled out now. 4my under root 1 plus m square is equal to 2y. So 4my is equal to 2y root under 1 plus m square. Y and y will get cancelled out. You are remaining with 4m equal to 2 root under 1 plus m square. I can write this as 16m square is equal to 1 plus m square. So 16m square is equal to 4 plus 4m square. So 12m square equal to 4. M is equal to 1 by 3 under root. Now you know that m is basically equal to what? M is basically equal to what? 1 by 10 theta na? And that is equal to 1 by root under 3. So that means 10 theta is equal to root under 3. That means theta equal to 60 degree. So this becomes a condition for the hydraulic efficient section in a trapezoidal section. Theta will be 60 degree. So if you go to the back slide, don't worry, I will give you time to note it down. This theta will be 60 degree for the hydraulic efficient section. This theta will be 60 degree for the hydraulic efficient section. Okay. And m value will be nothing but equal to 1 by root 3. M value will be nothing but equal to 1 by root 3. I hope it is clear to all of you. Okay. So this point kindly note it down quickly. Do done quickly. Once it's done, please tell me. Okay. Now just try to implement these things. So what are the things which we got here till now? First thing, for hydraulic efficiency condition, what we got, everything we are going to calculate it. So condition for hydraulic efficient condition for hydraulic efficient trapezoidal section. Condition for hydraulic efficient trapezoidal section. What is the first condition we have? First condition which we got, that T will be equal to sum of length of sum of the length, yeah, sum of length of inclined side. Second thing, theta will be 60 degree, m will be equal to 1 by root 3. Third, now if you put this condition T equal to sum of length of the inclined side, R value, hydraulic radius value, how much you are getting? Y by 2. This you all guys can do it. R equal to area by perimeter. Put this condition, B plus 2my is equal to 2y root under 1 plus m square. R equal to y by 2 you will get. So this is very important, that for hydraulic efficient section in a rectangle, in a trapezoidal section, for hydraulic efficient section in a trapezoidal section, R will be equal to y by 2. This point is very important for all of you. Fourth point is again very important for all of you. This point first I am writing, and then I will tell you with the figure also how it is possible. Okay. In hydraulic efficient section, trapezoidal section will be a regular hexagon, will be a half of a regular hexagon. I will show you this with a figure. First note it down. I will show you this with the figure. So how it is, actually this trapezoidal section will be actually it's a half of the regular hexagon. If it is a hydraulic efficient section, it will be half of the regular hexagon. First note it down these things. I will show you how. First note down each and everything. Then I will show you how it is possible with the figure. Now I'm showing it to you, all of you. Just look at, my dear. Okay. This is a hexagon. This is a half of the hexagon. How it is half of the hexagon? Look at this angle. You are telling it's a 60 degree. Okay. So if this is 60 degree, this will become 120 degree. Here also it is 120 degree. It is nothing but a hexagon, na? It is nothing but a hexagon, na? So how you can show it to you? Look it. It is nothing but the hexagon, half of the hexagon. Another property of the hexagon will be also valid here. Like one of the property is from the center, if you draw a line perpendicular to any side, perpendicular to any side, first this distance will be like OA, OB, OC will be same. OA, OB and OC all are same. All are same. And if you take this OA or OB or OC as a radius, and if you draw a semicircle in it, just like this, how I am drawing. If you draw a semicircle with it, it will pass like this. So basically a semicircle of radius this is inscribed in a half of the regular hexagon. This is another property which you need to remember, that if a semicircle is drawn with a center of the top width as the origin and the depth of the flow as a radius, it will touch all three sides of efficient trapezoidal section. That is nothing but a regular half hexagon. So this you have taken as center, this depth you have taken as a radius, and then you have drawn a half semicircle. It will touch each and every side of the regular hexagon. It will touch each and every side of the regular hexagon. So this is another properties which you need to understand. So these are the four conditions for the hydraulic efficient section in a trapezoidal section. I hope it is clear to all of you. I hope it is clear to all of you, my dear. If anybody having any doubt till here, they can tell me. If anybody having any doubt till here, they can tell me. Up to this, you guys have noted down. So this is nothing but the regarding trapezoidal section. Now one more section I will be discussing with you. That is nothing but the circular section. That is nothing but the circular section. Okay. So for circular section, as the circular section is having a converging boundary, here we are having two different conditions which you need to directly write it down. That for maximum velocity we have different condition for hydraulic efficient section. For maximum discharge we have different condition. So here for maximum velocity R we have different, Y we have again different. So here Y we have 0.81 D. D is the diameter here I am talking about, and this will be 0.3 D. Here it will be 0.9 D, 29 D, and here it will be 0.93 D. Here D is the diameter. Here D is the diameter. So you can put it here. D is the diameter of the. Okay. Sir, Hindi में कब पढ़ाओगे? Whenever class will be scheduled, definitely few days, like 1 week before, they will inform you. So don't worry about. I think in English also you can enjoy, na? Turtle. Even your username is nothing but an English name only. I'm not using some heavy Sasi Tharu type of English. Basic English I'm using. So you all can watch it, no problem. Anyway, exam question will be in English only. So in circular section, for maximum V, R is equal to 0.3D, Y equal to 0.81D. For maximum Q, R is equal to 0.29D, Y equal to 0.93D. These are the condition for the circular section. These are the condition for the circular section. So your hydraulic efficient section will be completed. Tomorrow I will be discussing 3 topics: specific energy, discharge curve, and specific force. 3 important concepts I will be discussing. So tomorrow we'll meet again at 8 p.m. sharply. Till then, thank you all of you. Bye bye. Take care. Good night.